today is density. Density is a quality of the material. Basically, this table has a density. You have a density. Your backpack has a density. Carbon has a density. Everything out there has its own density. And that is what we're going to start to discuss today, is density. So density is defined as the mass of an object divided by the volume of the object. Mass can have the units of grams or kilograms or even pounds. It is a weight volume. It is a weight unit. The volume of the object can come as milliliters, liters, centimeters cubed, or a variety of other volume units. So basically, density is a derived unit that takes into account mass and volume. So I can say, what is the density of an object that has a mass of 0.126 grams and a volume of 1.25 milliliters. For this particular calculation, it is simply using the equation for density. Density, which is often represented with a lowercase d, is equal to the mass divided by the volume. So it's going to equal the 0.126 grams divided by 1.25 milliliters. Or in other words, it has a density of 0.1008 grams per milliliter. Now we do have to think about significant digits. The mass has 3 significant digits. The volume has 3 significant digits. Because this is multiplication and division, the answer will have the same number of significant digits as the measurement with the fewest. The measurement with the fewest had 3, so the answer should have 3. So this would be recorded as 0.101 gram per milliliter. Notice the units. We took grams and divided it by milliliters, so it's gram per milliliter as the unit for the density. How about this one? What is the density of gold if 24.492 kilograms of gold has a volume of 1.256 liters? Give the density in grams per milliliter. What I notice is that the density is equal to the mass divided by the volume. And I specifically want, but I was given the mass in kilograms, but I want the mass in grams. And as far as the volume, I want the mass in, the volume in milliliters, but I was given it in liters. So you're going to have to do some conversions before you do your calculation. So 24.492 kilograms. 1 kilogram is 1 times 10 to the 3rd grams. Or in other words, it's 24,492 grams. The volume was 1.256 liters. And I want it in milliliters. 1 milliliter is 1 times 10 to the minus 3 liters. So it is 1,256 milliliters. Now that I have the units like I want them, grams and milliliters, I can use my density formula, as the density is the mass to 24,492 grams divided by the volume, 1,256 milliliters. And when you key this into the calculator, you get a density of 19.5 grams per milliliter. significant digits. Your mass had 5 significant digits. Your volume has 4 significant digits. This is multiplication and division. According to multiplication and division, the answer will have the same number of significant digits as the measurement with the fewest. The measurement with the fewest had 4, so our answer needs to have 4. And therefore, you would record this answer as 19.50 grams per milliliter in order to give it 4 significant digits. Questions? Okay, let's take a step back and talk about how we get these numbers. How do we determine the mass? Well, the mass is typically determined by a balance. So in other words, we have something very similar to a scale that we drop the object on and we get the mass. The trickier part is determining volume. Volume can be determined in a number of ways. If it is a regular object, meaning it has a regular shape, then we use geometry. We use rulers and geometry. So, for example, if we have a square object, the volume is going to be equal to the length times the width times the height. If we have a cylindrical object, then the volume is equal to 4/3 pi r cubed. Now, I'm not expecting you to know these geometry equations. The only one that you probably should know right off the top of your head is going to be volume is equal to length times width times height. For a square, for anything rectangular or square. But anything else, you'll be given that equation. So for a regular, that's for a regular object. But in chemistry, a lot of our objects are irregular. I mean, I gave you an example of you. You cannot determine your volume using geometry. Not very easily, at least. You can, a backpack, its geometry is not a normal shape. So, how can we determine an irregular object? We do that usually through submersion in something like water. And the reason we can do this is because no two things can occupy the same space. So the volume of the object will be the difference between the initial volume of water and the final volume of water. So let's see this in action. Or these in action. A regular object measures 1.0 centimeters by 2.0 centimeters by 1.6 centimeters. It has a mass of 2.16 grams. What is the density of this regular shaped rectangle? So if we're thinking about this, basically what we're saying is we have an object that is fairly regular in shape, or is regular in shape. It is 1.0 centimeters by 2.0 centimeters by 1.6 centimeters. In this case, volume is going to equal the length times the width times the height. So the volume is equal to 1.0 centimeters times 2.0 centimeters times 1.6 centimeters. Or in other words, the volume is 3.2 centimeters cubed. It is centimeters cubed because a centimeter times a centimeter times a centimeter is a centimeter cubed. Now that I know the volume, I can get the density. Density is mass divided by volume. So it's going to equal the 2.16 grams divided by the 3.2 centimeters cubed. Or in other words, it has a density of 0.675, and that's grams per centimeter cubed. Looking at significant digits, your starting mass had 3 significant digits. Your volume only had 2 significant digits, and it only has 2 significant digits because there were 2 significant digits in the 1.0, 2 significant digits in the 2.0, 2 significant digits in the 1.6, and therefore we only had 2 significant digits in our volume. Since the measurement with the fewest had 2 significant digits, our answer can only have 2 significant digits, and therefore this would be recorded as 0.68 grams per centimeter cubed. Questions so far? Let's look at another problem. An irregular object with a mass of 0.952 grams was placed in a graduated cylinder with .0 milliliters of water. The water level rose to 24.4 milliliters of water. What is the density? Of the object? Okay. So I mentioned the fact that with an irregular object, we do it through submersion. In this particular case, what this is describing is we have what is known as a graduated cylinder. And in this graduated cylinder was 20.0 milliliters of water. When the object was dropped into the water, that object came to rest on the bottom of our graduated cylinder. And what it did is it caused the volume to rise to 24.4 milliliters. Since no two things can occupy the same space, the volume of the object is going to equal 24.4 minus 20.0 milliliters. Or in other words, the object has a volume of 4.4 milliliters. Once you have the volume, you can get the density because density is mass over volume. So it is equal to the 0.952 grams divided by the 4.4 milliliters. Or in other words, it has a density of 0.2164 grams per milliliter. Now to figure out significant digits. The volume was subtraction. So it's the decimal places that matter. We had one decimal place in each of the volumes, and therefore our answer could only have one decimal place. So the volume has two significant digits. The mass had three significant digits. Since the measurement with the fewest had two significant digits, our answer can only have two significant digits. And therefore, you would record your answer as 0.22 grams per milliliter. Questions? Folks, what you should be noting comes back to the way I said that these values were determined. Mass, you simply place the object on a balance, a scale, and you get the mass. So the mass is always a given number. It's the volume that we have to figure out. And the volume can be determined using a couple of different methods. It all depends upon whether it's a regular shaped object or an irregular shaped object, the method that we tend to use. Now in chemistry, 90% of the time, it's going to be an irregular shaped object because we don't deal with nice, neat squares that often or nice, neat cylinders that often. We tend to deal with things that are very irregular shaped. And so submersion is the most common way to determine the volume. But once you have the volume, then density is not hard. Its density is mass over volume. You always use that formula. Density is mass over volume in order to get the density of the object. Now, what can the density do for us? Well, if we have an unknown object, the density can help us determine what that object is. So we can actually go in with all these unknown objects that we play with, and we can go, let me go to a table that has a list of densities. And, oh, this one has a density of 19.5 grams per milliliter. Gold has a density of 19.5 grams per milliliter. I must have gold. Or this block of silver metal has a density of 2.17 grams per milliliter according to my calculation. Oh, let me check the table. According to the table, magnesium has a density of 2.17 grams per milliliter. There's a good chance that I have magnesium. So basically, we can take these densities, which are characteristic of the material, and we can compare that with a table. And from that table, we can sometimes figure out what we actually have. And that's how we use the density. Now, density is but one characteristic. And it's not, as we find out in chemistry, one characteristic by itself is insufficient to identify an object. But if you have multiple characteristics, then yes, you can usually identify the object. Any questions about how to calculate the density of the object? Okay. Then the next piece is using the density as a conversion factor, which I will discuss on Monday. I'm going to let you go study for your test, even though you only have about 10 extra minutes.
Let's go.